Hey there. So today we'll be talking about networking, or specifically what is networked, what isn't networked, and how you can, avoid networking or do it if you want to. Now, let's get right into it. So, over yonder, we have a write. Now, this write writes to this data model store. Data model stores are variables that are network synchronized. Now, if I change this here to true and then click this button, one of two things are going to happen. One, this is going to trigger the write, as you can see here. And two, the data model store here is going to update to true, which you can see here. Now, the important part here is when I press this button, it triggers the write. This is a local action. No one else is processing this action. So when I click this, only I am doing something. However, this display here is actually synchronized, so other people can see that I did it on the display. If I get rid of this, the write itself is now entirely local. However, this data model store here is a synchronized value. So that means that if this value changes, this value is then network synchronized. So if I change this to false, the way it works is that first this new value gets sent up to the host, and then from the host to everyone else. Now, this of course means that there is going to be a little bit of a delay between values changing, and that the more often you change this value here, the more work host has to do. And the more work host has to do, the more likely it is that you'll be starting to run into desynchronization issues where a lot of packets could start queuing up. So this is why it is good to try and avoid values like this when you can, if you don't need them. So one example for that is that if we go and make another write, what we could do is we could use a local. Now, a local will only work for anything where you immediately check the value. So for example, if I trigger this here, I want to immediately check the value after. That's great. That works. That's what local is essentially for. It's a variable that only exists for one context. After that context, if you try to check it again with a different pulse, this is going to be its default value again. However, we have store, which has a stored value, which is similar to the data model store. However, it's a data model store without the data model part. So it essentially does not network synchronize because of this. So if I actually pull this out like this, again, let's write true to it. If I pull this out, you'll see that it's now true. However, for anyone else in the session, this would still be false. This has the upside that not only am only I processing the write, only I am updating this value here, so host doesn't have to do extra work and everyone else doesn't have to do extra work. So anytime that something does not need to be updated for everyone else, you should be using a store. A very good example for this is anytime you make a state machine that has an end result, because if you're in between steps, if you're writing them, and then you have an end result that you're also writing, you can make it so that the in-between steps are actually stores, and your final step is a data model store or a regular field. This will make it so that at first, no one is processing anything except for you because you're not network synchronizing anything. And at the end, you're then letting everyone update the value. Now, networking goes a little bit farther than just Flux because it is everywhere. If I grab this and I move it, that was networking. That was just now networking. And the reason for that is if we open our dev tool and click create new and then make an empty object, we have now caused a networking event that essentially told everyone to create this object. So every time you create an object, that is also network synchronized. But further than that, an object always contains at least these fields here. So the name field, which is essentially a data model store, because every time I change this, everyone else also gets this in the exact same way that these data model stores here update, by sending to the host and from the host to everyone else. If I change this position here, again, it's a field that is not driven, therefore it gets sent to the host and then to everyone else. If I go to attach component and I make a data value field, let's make a byte, because why not? This is now a network synchronized value. And this is very important to keep in mind. Any field, for the most part, you work with in an inspector, any regular field will always, by default, be network synchronized. Now, there is some exceptions to this, but they are few and far between, and are mostly not network synchronized because they're driven from something that is already not network synchronized. So as an example for this, if I was to here now make a transform driver, and we'll go to Boolean value driver, and then we use byte, and we'll set the true value to 8 and the false value to 0. If I then grab this here and put it into the target field, this state field here is still network synchronized, but this field up here is no longer network synchronized. If I press this button here, because this is true, this value is then processing-wise computed to be 8. If this value is false, it's computed to be 0. This computation of what this value up here should be happens entirely locally. This means that if, for example, I then grab the state value with the ProtoFlux tip and create a drive, and this is one of the things you need to keep in mind as a word, drive, because that's also what we're doing here. We're driving something. If we create a drive here, you'll again see this purple color show up, where this field here now is processed based off of something else. So currently it's based off of this field drive here, which is giving it false. So anything that this state here is based on what comes before from this drive. If I hook it up to this data model value field store, it's going to be based off of a network synchronized value. So if I update this here to true, this here is going to also say true, and therefore everyone will see 8. However, if I hook it up to here instead, to the stored value, now for me, this is going to say 0 if I just joined the world. However, the moment I press this button, it'll say 8. But for everyone else, because it's a stored value, it will in fact not say 8, because the default value essentially is false. Therefore, the default value is 0. Now, this obviously means that since any field is network synchronized, that also means that you can localize everything. Now, this goes basically infinitely far and can lead to some problems. So when you're dealing with synchronization, always be a little bit careful that you know what you're synchronizing and what you're localizing. As an example, if, for example, sorry, I just repeated example twice. I know you do that a lot, probably. If, for example, we have this empty here and we were to drive its position, this is a ProtoFlux browser. We don't need that. We need to attach component, and we'd go to transform drivers. And I showed this component off, I think, in a past video. I'm pretty sure value user override, which is one of the easiest ways to localize something to a specific person. If we were to grab its position and grab this as the default, and then said create override on right. Now, if I change this here to x0, it'll be over here. And it should have, okay, it didn't create right now because I am silly and forgot one step, which is grab the position and actually put it into the target. That would be very useful. If you now change this value up here from -2 to 0, you'll see that it moves over there. But also, it'll now here show the value that it is localized to. So for me, it's 0, but for everyone else, it's -2. And I really like values override as just a showcase of networking, because it basically shows you what the actual true value for everyone else is and what the value that deviates from everyone else's. So everyone else sees x as -2, I see x as 0, and if we were to add another field here and someone else changed it to something like 5, then that would be where the object is for them. And you have to keep that in mind, because if you do localize certain values, you may run into the issue of exactly this. Some people see the object in a different place. So when you're dealing with positions, volume, anything like that, always make sure that unless it's something like a volume slider that you want to localize, but otherwise, make sure that everything you're doing is based upon some core event that is network synchronized, unless obviously you intend for it not to be. Because otherwise you might run into these issues where you have deviancies that you do not intend. There is obviously cases where you do intend deviancies, and let's talk about those. For example, this sphere over here. Now, let's say we want to have everyone in the session to have their own sphere to be inside of the sphere, or to be on top of the sphere. Now, what we could do is we could grab the sphere, and we could duplicate it, and then duplicate it, and then duplicate it, and have 1, 2, 3, 4 spheres. And let's say, yeah, we need 4 spheres exactly. And then in the future, we'll need 5 spheres. And in the future, we'll need 20 spheres and 30 spheres, depending on how many people are in this session. Now, we could keep doing this and duplicating sphere after sphere after sphere until everyone has their own sphere. Or we could make use of the thing that we just talked about being unintended, where everyone sees it in a different position, but for our own purpose. So instead of having these different spheres, we could just have one sphere, and we just localize the position of this sphere. I'll actually make this a child, just so be a little bit cleaner. So we'll just go into transform, drivers, and we'll add a value user override of type, where is it? Float free, there it is. Right, so now we just grab the sphere's position, make sure that we get the current position first so it doesn't go into space. Oh, well, in this case, it would just go to the ground because that's where my 0, 0, 0 is. Okay, double like this and create the override on right. And now I can move the sphere either by changing this value here for the default value, which will make it a little bit more clean, because these values don't look that clean. I'd rather have something cleaner like this. There we go. And if we want to then adjust it, we can simply select the sphere and just move it. And if we move it over here, this is where it's going to be for me specifically, but for everyone else, it's still going to be here, which you can observe in here. So if I actually, let me just deselect first because I was moved the child instead. There we go. So if I actually move this now, you'll see that the value is updating down here. But yeah, that is basically everything I can say about this. Now, one more thing is that I want to reiterate that everything essentially, not really everything, but most things are network synchronized. And again, slots, specifically like creating, destroying slots, everything like that needs to be network synchronized. This also means that hierarchies are network synchronized. Now, hierarchies are a bit weird to explain, but the simple of it is this structure here, where you have a sphere and then a sphere child, that is a network synchronized thing. The fact that this sphere child is parented to the sphere needs to be sent to the host and then from the host to everyone else. Now, this can lead to some itty-bitty issues in systems that mess with hierarchies from one user's specific perspective. An example of this would be grabbable avatar systems, of which I have made one. Because what will happen in those cases is that when someone can be grabbed and picked up like an object, what can happen is that for themselves, they haven't been grabbed yet. Or even worse, the object that they are parented to for the other person doesn't exist for the initial person yet. Now, what this means is that they will still, for themselves, be moving locally to the slot that they're still parented to, which, for example, could be the root of the world. But for the other person that just grabbed them, they'll appear to be jittering as they move their hand, because while you can technically move the user locally, since the user themselves still thinks that they're not parented to it, they're not actually parented to it yet. So their global position is still going to be updating based on that. This means that if you, for example, grab someone, move them, and let go, it could very much happen that for a split second, they'll just go to 000 once they finally catch up with the grab, or worse, just get offset weirdly, because between you grabbing it, you moving it, and you letting go of it, the moment you let go, it could have destroyed the grabbable. So when you make systems like that, you need to be extra careful that you try to avoid this. Now, to talk more about the grabbable avatar system, the one that I'm working on, I actually try to get around this issue a little bit by having a new mode where instead of destroying the anchor the moment the other person lets go, it actually keeps it around for a bit. Basically until the user jumps out of it. You can disable this by re-enabling the auto-deparenting, but the upside here is that if the user never jumps out of the seat, so they're still anchored to the exact same anchor, what you can do is you can just grab that anchor again and move it, which will be a networked event that will synchronize a lot more gracefully, because if you think about it, instead of having to generate a slot, parent the user to that slot, and then move slot from A to B, and then move the person back off of that slot, what you're now doing is you're just saying, this slot moved to this position. This means that when you grab that person, you'll instantly see them moving now, and the moment you let go, you'll also instantly see them stop moving at that position. While the other person may initially not see that they've been grabbed, however, once the networking catches up, they'll instantly go from A to B. But yeah, I think this is as much as I can say about networking. I could talk a lot more about the intricacies of what you have to be careful about and everything like that. But yeah, this is pretty much it. Final thing I'll say is that, as we talked about, purple values, they're generally driven values. Values that are not purple generally are not driven. However, there is a caveat of there being some specific, like, systems level stuff that can still control the value, even if it's not showing up as purple. This would be, for example, stuff like the virtual parent, where if you, I think it was virtual parent, that even if you null the position and rotation, it will still update those values, and it'll not update at some point. Some of the IK component will actually continue to update even if you break the link. I think I can actually show it real quick by... Let's just take the leg. So here we have my leg, and you'll see that these values here are purple because they're based on my IK. So if I click this little button here, I can break the link, and you'll see that it's now broken. However, my leg still works normally if we look down here. And if I then break the rotation, you can see exactly why that is. Because while I did break the link, the component that is updating your IK does not care that you broke the link. It will continue to update those values and change them. Now, this is an exception to the rule, however, and I'm assuming that once we get the IK rework, that is also going to change most likely. But yeah, I think that's literally everything. 20-minute video, but we got there. I'll see you in the next one. Bye-bye.